Everybody want to say hi to Jasmine?
Hi,
Jasmine. Okay, we're doing section 1-4, part 2. Let me make sure this is centered. Okay, we'll see how it goes. There are going to be some problems where we need a calculator, so I have that up there. Make sure you've got yours. And I'm going to start with a rule that basically summarizes what we kind of talked about on Friday with those one-sided limits. So here we go. The rule says that the limit as x approaches c, the limit as x approaches c of f of x equals L, capital L, so that's going to be some kind of a number, if and only if. So there's going to be two parts to this. If and only if the limit as x approaches c from the right, the limit as x approaches c from the right of f of x equals L, that same number, and the limit as x approaches c from the left of f of x equals L. Okay, so basically this is saying that the limit of a function can only equal a number if the limit from the right is that number and the limit from the left is that number. So we actually already did use this rule on Friday, but we're going to use this again today with some of our problems. If they ask you specifically for the limit from the right, you could actually just try and find the limit overall, and it should be the same as what you would get just coming from the right, or same idea from the left. If it's the limit overall, then it should be the same no matter what direction you're coming from. Okay, so directions say, find the limit if it exists. Find the limit if it exists. We're going to try a few of them here. So, first one, here she is. We want the limit as x approaches 3 from the left, because there's a little minus sign there, from just the left of x minus 3 over x squared minus 9. Now, typically, if we're coming in from the right or from the left, we usually like to see that on a graph, but we're going to get to some limits like this one where they're not as easy to see on a graph. It might not be a really nice number. So what I'm going to do first on number 1 is I'm going to see if I could just find the limit as x approaches 3 overall. Forget for just a second that it says as x approaches 3 from the left. Let's just see if we can find it as it approaches 3 from both sides. So forget the left part for just a second. Now, what's the first rule in any limit problem? Yeah, plug in the value of x that you're approaching. If I tried to plug in a 3, I'd get an indeterminate form. 0 on top, 0 on bottom. So anybody see one of our other techniques that could work for finding the limit? Factoring, very good. Difference of squares right here. Make that x plus 3 times x minus 3. So the x minus 3's drop out. Now I'm finding the limit as x approaches 3 of 1 over x plus 3. Now if you take this value of x and plug it in, now we should be good to go. You're going to end up with 3 plus 3 on bottom, which is 6. So remember, if the limit as x approaches a certain number overall is 1/6, then the limit as it approaches it from the left should also be 1/6. I mean, that would be my answer, even if it said from the right. Because if the limit is 1/6 overall, without left or right, if it's the limit overall, it should be the limit coming in from both sides separately. Okay, any questions about that one? Pretty well just ignored the part about coming in from the left. Now let me erase this so we can see example 2. The limit as x approaches 1 from the left of, here we go, new function, absolute value of x minus 1 all over x minus 1. Okay, now remember, we're forgetting the left for just a second. If it was just the limit as x approached 1 overall, would I be able to plug in the 1 wherever I saw x? You could, but you get 0 over 0, and that's not good. Now, do any of our other limit techniques involve absolute value? We had factoring, we had complex fractions, we had radicals, but we didn't have anything with absolute value. So unfortunately, I'm not going to be able to do this just ignoring the left part. I'm probably going to be left with having to look at the graph and seeing what happens as I approach 1 from the left. At this point, we do want to remember that we're only coming in from the left. That is going to be important. So, on your graphing calculator, let's type this function into our y equals. You might not remember where absolute value is, but I will show you. Oh darn, I had this typed in for something later on. I'll clear it out for now. Okay, absolute value. I'm going to go, I probably can get away without parentheses here, at least on top. I'm going to go to math and then write 1 to highlight num. Absolute value should be your first option there. What did we want? We wanted x minus 1. Now, when you type in the part on bottom, you actually probably need, you actually probably need to put that part in parentheses, x minus 1. That way it divides it by everything. So if all else fails, we can look at the graph. Now, the reason we couldn't use any of our other techniques on this problem is because if you come in from both sides, the limit does not even exist. That's why we couldn't really use that rule to just find it overall. If you come in from the left and from the left only, as you approach x equals -1, what y value are you approaching? -1. You're not really approaching it. You're right on -1 the whole entire way. So answer for this limit problem would be -1. And again, we had to do that by looking at the graph only because none of our other techniques worked. I wouldn't try to graph right off the bat because I don't think a graph would have helped us too much on number 1. It's hard to see 1/6 on a graph, but this one wasn't too bad. Any questions about the first two? We're moving here. What do we do? This is example 3. What do we do if it's a piecewise function? We are supposed to find the limit as x approaches 2 from just the right of x squared minus 1 when x is less than or equal to 2, and then 2x minus 3 when x is greater than 2. But we only want to approach 2 from the right. Now, I may actually show this on a graph first, and then we can maybe kind of summarize it into some kind of a rule to use when we have piecewise functions. But if you think about typing this in, this is what I had in here earlier, but I'll do it again real quick. Remember, you have to kind of put the piece in parentheses with the condition right after it in parentheses. So, x squared minus 1, end my parentheses. Right after that, I need my calculator to know that this is only good when x is less than or equal to 2. Now remember, test is what you want for the inequality symbols. Second, math brings up test. This is something you need to know how to do. Okay, and I want that to be less than or equal to 2. Now to put the pieces together, I'm going to just put a plus sign right after that. And here comes the second piece. 2x minus 3, end parentheses, start parentheses. That is only when x is greater than 2. So again, second, math brings up the test button. I want greater than, and I want 2. Okay, which direction are we coming in from? From the right. We're coming in from the right, and we want to approach the x value of 2. This is where x is 2. If I came in from both sides, it would not exist. But coming in from the right, what y value are you approaching? 1. Yes, there's actually a hole right here, but it doesn't matter. As you get closer and closer to where x is 2 from the right, the y value is just 1. Okay, so that's going to be our answer for this problem because we only wanted to come in from the right. Now, thinking about maybe an easier way to do this. Anybody know of a way to get the 1 without even graphing it? Think about your function. Think about coming in from the right. Coming in from the right. If you're coming in from the right, your x values are greater than 2. If you're coming in from the right-hand side, you're greater than. So actually, since this is the behavior where x is greater than 2, I could have just taken that second behavior and plugged in the x value that I'm approaching. If I put in a 2 right there, 2 times 2 minus 3, that would be 4 minus 3, and that would be 1. So to kind of make it easier on you, if you can just remember, with a piecewise function, if you're coming in from the right, you should use the second piece because it's always going to have the greater than symbol. If you're coming in from the left, you should use the first piece because it's always going to have the less than symbol. That can save you some time. Okay, coming in from the right, use the second. Coming in from the left, use the first. Now, what do we do on example 4 when it doesn't tell me left or right? Example 4, I want the limit as x approaches 1 overall of x squared plus 1. That is just when x is less than or equal to 1. And then negative 3x plus 4, that is when x is greater than 1. Exactly, yes. If they don't tell you which side to come in from, then you have to plug that value that you're approaching, plug that 1 into both parts. Now here's the deal. I'm going to add to this a little bit here. You might want to write this down. Remember, the rule said that if the limit equals L, whatever L is, then it should equal L coming in from the right and coming in from the left. So, in other words, the limit from the left and from the right should agree with each other. What that means is they should be the same. If they're not the same, then we have an issue. But we need to check and see that they agree with each other. We need to check and see that they are the same. So, I'm approaching 1. So let me plug in the 1 to the first behavior. 1 squared plus 1, that would be 2, obviously. Plug it into the second behavior, -3 times 1 plus 4. That ends up being a +1. What you get coming from the left does not equal what you get coming from the right. They do not agree with each other, so please don't leave your answer as 2 and 1. Remember, the limit is a single y value, and these are not approaching the same thing. Now, again, you could have graphed that, and you could see from the graph that you're approaching 2 different y's, but it's a little bit quicker just to plug them in. Any questions about finding limits from piecewise functions? Not too bad. Hello, welcome back. This is section 1-4, part 2. If you want to just jump in, I'll get some notes to you here in a second. Now, the last thing that we're going to talk about today is something called the greatest integer function. We're adding one more function to our list here. And I think I pointed it out from the homework last night. But we need to kind of know how it works. Eventually, here in just a few minutes, we're going to find the limit involving greatest integer functions. But for now, I don't think you've seen this function before, so I want to explain how the function works first. And then we'll see about finding the limit with it. Okay, so it's got some fancy looking brackets. This is like the parent function. F of x equals, I would just say that that's the greatest integer of x. Okay, now here's what the greatest integer function does. This is important because you have to know how it works. Anytime you see those fancy looking bars, then it means that you're trying to find the greatest integer. I'm trying to remember what integers are here in a second. The greatest integer less than or equal to x. The greatest integer, or in other words, the biggest integer, less than or equal to x. Now, remember integers. They can be positive, they can be negative. You could even have 0. 0 is an integer, but you can't have fractions or decimals. It's just that number by itself. So just to kind of practice this a little bit, this is not an example, this is not even a limit problem, but let's say that we were trying to find the greatest integer function of 4.02. Greatest integer of 4.02. What that means is we need to find the biggest integer less than or equal to 4.02. What's the biggest integer less than or equal to 4.02? Anybody know? 4. It's an integer. It can't have fractions or decimals. So my answer for that would just be 4. That's the biggest number less than or equal to 4.02. Now what if it had a 3.99? What's the biggest number less than or equal to 3.99? 3. 3. It can't be 4 because it has to be less than or equal to that number. Now, I'm going to put a few more up here. Feel free to write them down if you want. If you already have an integer in there, then it's just going to be that number. Remember, it can be equal to x, whatever x is. Now, actually, you might want to think about negatives a little bit. Sometimes negatives are a little bit different. What is the biggest number less than, or I should say biggest integer, less than or equal to negative 3.99? Less than. Negative 4. It can't be negative 3. Up here it was positive 3, but remember it has to be less than. If you put negative 3 right here, negative 3 is actually bigger than negative 3.99. We can do that again with a negative 4.02. What's the biggest number less than or equal to negative 4.02? Yeah, so it doesn't really round it necessarily. It's just the biggest number less than or equal to whatever is in those fancy brackets. Okay, so our last example, it is going to be a limit problem, but it's going to have a greatest integer function in it. Don't worry about the graph. I'm going to get right to this. Example 5. Okay, we want the limit as x approaches 3 from the left of 2 times the greatest integer of x plus 1. Follow with me here, because this is a little bit different than what we've been doing. Okay, first thing I have to point out, right here, we want to approach 3 from the left. Now, because of this new function here, we're going to have to think of this maybe a little bit differently. So what I'm going to do is I'm going to plug in a number, really close to 3 from the left. These don't work quite the same as our other functions did. Since I'm coming in from the left, I want to plug in a number really close to 3 from the left. Now let me think about this. I'm kind of talking about a number line. Think about a number line for just a second. A number really close to 3 from the left. I mean, you can use whatever you want to use. It just needs to be really close to 3 from the left. I'm going to go with a 2.99. So let me see, once I plug this in, I actually can probably just leave that limit part off for just a second. If I plug in that x value really close to 3 from the left, so I picked 2.99 because that's really close to 3 from the left. Now, we can simplify that and see what it works out to be. If you look at this part right here first, what is the biggest number less than or equal to 2.99? 2. So I still have this other 2 out front. But now the 2 out front is getting multiplied by the other 2 that I got from this. And then here we go. 2 times 2 is 4. 4 plus 1 is 5. Okay, it works a little differently. It's not that you're just plugging in the 3. I don't think we would have gotten the same answer that way. You have to kind of think about which direction you are coming from. Okie doke. Yes.
If there wasn't like the left sign, would you just plug the 3 in?
You would, yes. You would just plug the 3 in. Anybody else? Okay, I'm going to go ahead and put the assignment up here. This is C22 from page 96. All right, we're going to do number 21. But notice you don't have to do number 11. You can skip number 11. As you're doing the limit problems, try our techniques first. If our techniques don't work, then you can always try to graph.